So here's a few more observations about these Poncelet families of triangles inscribed in an ellipse and circumscribing a circular conic. And I want to cover on this video our capability of shrinking some loci to points. So for example, for the locus of x2, which is a homothetic copy of the outer ellipse, we can always shrink it to a point by placing C in a particular location of the minor axis of the outer ellipse. And of course, I can always go down to the symmetric position down here. Okay, now it turns out that for this particular location where x2 is shrunk to a point, and by that I mean there's a family of triangles for which their barycenter is stationary. It turns out that this is the same exact location of C that will shrink the nagel point to the center of the system. So recall that the nagel point locus was an ellipse, homothetic and concentric to the outer one. But when C is on that particular point that shrinks x2, the locus of x8 is shrunk to the origin of the system. So you get the sort of symmetric situation here. And this is an interesting family, right? Nagel point is frozen at the origin. What are conservations of this family? Are there any conservations? We can see here that circumradius, big R, is not being conserved. And this is the exact same C that will make x2 remain stationary. So it could be that it's an easy proof to show that both of these points are necessarily stationary if either one is stationary. So if x2 is stationary, that implies because of x1, perhaps, because x1 is stationary, right? So maybe x8 is a combination of x1 or some reflection of x2 on x1 or something of that sort. So we got that phenomenon. So what are interesting properties of such a family? I haven't seen it before. Perhaps it's known. Now, with C over here, is x3 stationary? No, x3 is not stationary. In fact, there's no way we can actually shrink x3 to a point. Okay, it kind of tends to a line, to a segment when C is very close to the boundary, but I haven't been able to shrink it to a point. What we can do is place C right in the middle of the system, and then the locus of x3 becomes a circle. Now, what's interesting about this family, we've studied this in past publications, is that it conserves the circumradius. I'm not showing the circumcircle here, but the circumradius is conserved. It's a very interesting family. And x3 describes a circle. Note that the two foci of the circle are on the origin. So we keep that property that we actually mentioned in the previous video, that the two foci of the x3 locus, each one of them is in a separate semi-axis of the outer ellipse. Okay, so we can't shrink x3 to a point. How about x4? As we saw before, yes, we can shrink the upright locus and homothetic locus to the external of x4 by finding a particular position on the x-axis, on the major axis of the external, for which x4 will shrink to a point, not any point, but one of the focus of the external. Again, this is, to me at least, an interesting family. I haven't studied it before. It's a family of triangles with fixed orthocenter. Are there interesting properties to this family? Are there interesting conservations and interesting geometry to this very interesting set of triangles with a fixed orthocenter? Now, if I now go over to x5, I haven't been able to shrink x5 to a point. It's reminding me of that American movie, Honey, I Shrunk the Kids. I can't shrink this kid to a point. Okay, at least not in an obvious way here. Yeah, it looks like one thing we can do is shrink it to a segment. So if I stop that, there's a position of C that seems to be annihilating one of the semi-axes of the x5 locus. So what are those four positions, right? You're going to get these four symmetric positions here of C that annihilates one of the semi-axes. Looks like the minor semi-axis of x5 is being annihilated. So the locus of x5 becomes a segment. I haven't been able to find a position here that will annihilate both axes of x5. Okay. How about x7? x7 can get annihilated, both axes, for another point on the major axis of the outer ellipse. So here we have an interesting family where all these triangles have a stationary Jargon point. Now, interestingly, this is not the same point on the major axis that annihilated x4. So to annihilate x4, I have to go back a little bit, and then I can annihilate it. Now, so I think that's all I have, right? I've already covered x8. x8 can only get annihilated if C is on the y-axis, on the minor axis, and it's annihilated in the same location for which x2 is annihilated. Okay, so that's all I have. Thanks for watching, and I'll see you hopefully on the next video. Honey, I shrunk the triangle centers. Should be the title of this one.